Okay. Are you able to see the contents on the screen, guys? Are you see? Can you able to see the contents?
No, sir.
Contents on the
No,
screen?
sir.
No. Okay.
Yes, sir.
Yes, sir. Now I can.
Okay. Okay. Are you able to see? Are you getting the things like screen? Are you seeing? Okay. You can see the contents on the screen.
Yes, sir.
Okay. Are you able to
Yes,
Yes,
sir.
sir.
see?
Yes, sir.
Okay, 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 okay. So this is called your steam tables. Okay, so this one I took from a standard steam tables written by R.S. Kurmi, the standard values. Okay, so same thing you'll get in the exam steam tables. Okay, so there are two things. You see, table one, saturated water and steam tables on temperature base. Okay, as I said, we are having the temperature base and pressure based. Okay, they'll ask find out the steam properties at temperature of around 100 degrees Celsius. We are having the temperature from 0 degrees Celsius to, you see, the left side, okay, extreme left, 70, 71, like that you can observe. This all indicates the temperature. This is the temperature based steam tables. Okay, okay. Suppose I want to find out what are the properties of the steam at 99 degrees Celsius. Okay, and the first column is your pressure. Okay, at 99 degrees Celsius, your pressure is 0.97 bar. You remember, this is in terms of bar. And Vf is your specific volume, 0.001. And Vg is 1.73. You see, there are so many columns. First one is temperature, second one is pressure, third one is Vf, that is specific volume of wet steam. This is the saturated steam. HF, these three things are most important. You remember HF, HFG, and HG. So these are the things we are going to take in our numerical problems. Okay, HF is your sensible heat. Okay, at 99 degrees Celsius, 414.8 is your HF, and 2259.6 is your HFG, and HG is your the total enthalpy. It is summation of 414.8 plus 2259. That gives your 2674. Okay, just very simple. We are having the two tables. One is a temperature based table and second one is a pressure based table. What I am explaining right now is your temperature based table. How to get the properties of the steam at a particular temperature from 0 degrees Celsius. It starts from 0 degrees Celsius to your how much maximum range is up to see so much up to 400, 500. Okay, up to 3174.15. Okay, I already studied. This is called as absolute zero temperature. Okay, so you can find out the properties of steam at any temperature. Whatever the left column is your temperature. Okay, now I'm explaining what are the properties at 99 degrees Celsius. Like that, you can find out the properties at any temperature. So, and what about HF is 414.8 and HFG is 2239.6 and HG is your the total enthalpy 2674. And you can observe here SF is your entropy 1.296 and SFG. These are rarely comes into picture. Mainly you have to concentrate on temperature, pressure, and these three values are most important. Okay, temperature, pressure, HF, HFG, and HG. Like that, you can find out the properties at any temperature. Now I'm taking another value. Now I want to find out the steam properties at 140 degrees Celsius and corresponding pressure. You see, immediately after temperature, you are having the pressure column. So sometimes they ask what is the pressure at 140 degrees Celsius. At 140 degrees Celsius, pressure is 3.61 bar. Okay, and this is the specific volume of steam. And HFG is your sensible heat of steam. Okay, how much amount of the heat is required to convert 1 kg of water to 1 kg of wet steam at saturation temperature. That is called as your sensible heat. Already you studied a pH diagram in a BTD. Okay, so this is HF. and this is HFG, and one more is HG. Like that, we can find out the properties at any temperature. So first you have to understand how to see the steam tables. You'll get the steam table in the exam. Okay. And second part is your table 2. Table 2 is your pressure based table. You see, we can observe heading is your table 2. That is saturated water and pressure tables. Okay. So what are the values gives here based upon your pressure? Okay. Suppose I want to find out the properties at zero point 0.1 bar pressure. Okay. And you see the pressure varies from 0.0061 bar to how much? Maximum ranges like that. We are having minimum to maximum. Okay. Around 0.1 bar pressure. Okay. So this is a table 2 pressure based table. When the pressure is given in the problem to find out the properties of steam. Okay. For example, I am taking zero point 0.1 bar pressure. What are your properties? Okay. Like zero point 0.1 bar is there. You see, you can observe, and corresponding temperature is 45.8. Okay, so this is the temperature corresponding to your pressure. Then remaining value, HF is your 191.8, and then HFG is 239.2 and 2584.7. Okay, just very simple pressure based table and temperature based table. Table 1 gives your temperature based. For a given temperature, we'll get the corresponding pressure, the values of specific volume, HF, HFG, HG, and the specific entropy. They are clearly mentioned at the top, you see. One is pressure, second one is temperature, specific volume corresponding to this pressure, what are the values, okay. So using these steam tables, we are going to find out the properties in solving the problem. For example, you had one formula in steam nozzle. What is the formula? C equals to square root of H2 minus H1 or H1 minus H2. So how we are going to find out H1? H1 is your HF plus X into HFG, that one formula. Then how we are going to find out that HF and HFG corresponding to particular pressure, we are going to find out HF and HFG. You remember C2 is square root of H1 minus H2. H1 is what? HF1 plus X into HFG1 if it is a wet steam. If it is dry steam, what? Directly you can take HG directly, okay, because the dryness fraction X is 1 in case of dry saturated steam. Okay, for that purpose we need all these values. Okay, I hope you understood how to see the values. Okay, because before solving the problem you should know the idea of your Mollier diagram and steam tables. Okay, any doubts guys how to see, because you should know how to see the steam table. Any doubts in steam tables? Any doubts?
No, sir.
Okay, there are two things you remember. One is pressure based table. Table 1 is your temperature based table. I shared all the steam tables in your WhatsApp group as well as in Google Classroom. Just you refer, you will come to know. Okay. Uh, First one is temperature based. From the temperature, you are going to find out all the properties. And pressure based table, for a particular pressure, you are going to find out the remaining properties of the steam. Okay. Now I'll explain one problem. Okay. Are you able to see the contents on the screen? Yes. Okay. Are you seeing the contents? Are you able to see the contents? Whatever I shared on the screen?
Yes, sir.
Okay. I'll start the problems in steam nozzles. Okay. First, I'll start with very simple problem. Okay. air is allowed to expand reversibly and adiabatically in a nozzle from 13 bar pressure and 150 degrees Celsius, okay, to a pressure of 6 bar, okay. The inlet velocity of the nozzle is very small until the pressure occurs under steady state condition. Calculate the exit velocity of the nozzle, okay. So we know that the C2 equals to square root of 2000. As I said, when you are going to put H1 and H2 in terms of kilo units, you have to multiply by 2000, multiply by 2, because that comes in your formula, plus C1 square. As I said, whenever C1 is there given in the problem, you have to consider C1, but otherwise you neglect, because the inlet velocity is too small as compared to your exit velocity, okay. And you remember the formula for exit velocity of the nozzle, square root of 2000 into h1 minus h2, okay. You can find out, there are so many ways to find out h1 and h2. H1 is your uh, hg in case of you, by using the steam table also you can find out, by using the Mollier diagram also you can find out. There are so many ways. And one more standard formula for enthalpy is, you studied in thermodynamics, that is always given by Cp into delta T. That is the formula for enthalpy, remember. And one more we studied, that is internal energy is always given by delta U equals to Cv into delta T. Whereas H is enthalpy is always given by Cp into delta T. Delta T means what? T2 minus T1. You remember enthalpy formula is Cp into delta T. Change in internal energy is Cv into delta T. Okay. So H1 minus H2 is Cp into T1 minus T2. Okay. As I said, specific some values you should remember. Cp is always your 1.005. Suppose they are not given in the problem, you have to assume. And the Cv value is what? 0.718. And how about gamma? 1.4. These are the three values you should remember. Okay. So H1 minus H2 is Cp into T1 minus T2. Cp is your what? 1.005. What about T1? T1 is given 150 degrees Celsius. You have to convert in your Kelvin. 150 plus 273. That will get 423 Kelvin. Whatever is there, you have to put it in Kelvin. Don't put in degrees Celsius. Okay. So H1 is Cp. H1 minus H2 is Cp into T1 minus T2. We know T1, that is 423, and T2 we don't know. Okay, then how to find out? They are given clearly in the problem that is a expansion is your adiabatic process. You studied in a reciprocating air compressor, that is relationship between temperature and pressure is given by T2 by T1 equals to P2 by P1 to the power of gamma minus 1 divided by gamma. Same formula you are going to apply here. Okay. Remember, T2 by T1 equals to P2 by P1 to the power of gamma minus 1 divided by gamma. Gamma always you have to take it as 1.4. T2 is unknown. T1 is 423 Kelvin and P2 is exit pressure. How much exit pressure? It is 6 bar and inlet pressure is your 13 bar. So by substituting all the values, you'll get the value of T2. So T2 by T1 equals to P2 by P1 to the power of gamma minus 1 divided by gamma. Okay, this one you observe the formula. T2 by T1 equals to P2 by P1 to the power of gamma minus 1 divided by gamma. So T2 equals to T1 into P2 by P1 to the power of gamma minus 1 divided by gamma. Okay, so T1 is how much? 423 Kelvin. P2 is exit pressure 6 bar and inlet pressure is 13 bar. Okay, and to the power of 1.4 minus 1 divided by 1.4, because in the problem they are given it as adiabatic process. Adiabatic means the value of gamma will be always 1.4. So after substituting, you'll get the temperature as 339.15 Kelvin. Okay, so we will get the value of C2 as square root of 2000 into 1.005 into 423 minus 339 degree Kelvin. Okay, so after we are getting it as 410.53 meters per second. You see, so this is very high as compared to your inlet velocity. Inlet velocity is almost negligible in case of a nozzle. Okay. So, and one more, you can find out the H1 and H2 by using any formula. You use what I said, you can use the Mollier diagram. So you can use your steam table, or you can use the analytical formula, whatever the way you do it, but you should get the final value as approximately 410 meter per second. Okay. So just you remember the formula. First one is square root of 2000 into H1 minus H2 plus C1 square. In the problem they are given inlet nozzle velocity is 0. Okay, almost 0, no value. Okay, square root of 2000 into h1 minus h2. H1 minus h2 is your cp into t1 minus t2. Remember, cp into delta t. Cp is 1.005, t1 is inlet temperature, and t2 is, you are going to obtain by the formula T2 by T1 equals to P2 by P1 to the power of gamma minus 1 divided by gamma. So, substituting all the values, we are getting a T2 as around 339 Kelvin. So, C2 will be square root of 2000 into 1.005, 423 minus 339.15. So after solving, we are getting the value of C2 as 410 meter per second. Okay, this is a very simple problem. Okay, now I'll take how to solve using your Mollier diagram. Okay, Mollier diagram. Okay. Problem 3. Okay, this is how I hope you understood how to find out the values of h1 and h2 using Mollier diagram. Okay, just today I'll explain the problem. Dry steam is allowed to expand in a nozzle from a pressure of 12 bar to 0.95 bar. If the frictional loss in the nozzle is 10% of a total drop, calculate the mass of steam discharged when the exit diameter of nozzle is 12 mm. So this is the problem. Okay. So what are the given condition? Dry steam means dryness fraction is 1, is allowed to expand in a nozzle. Always the expansion process happens in the nozzle from a pressure of 12 bar to 0.95 bar. You remember, in case of nozzle, pressure decreases and velocity increases. P1 is 12 bar and P2 is your 0.95 bar. Okay. If the frictional loss in the nozzle is 10% of total heat drop, because in this problem always the heat losses takes place, whatever equipment you take, the heat losses takes place. It is 10% of the heat losses takes place in the nozzle. Calculate the mass of steam discharge. Means you are going to calculate how much amount of the mass of the steam is flowing inside the nozzle when the exit diameter of the nozzle is 12 mm. Okay. Now you have to write the given data. Okay. So P1 is your 12 bar. Okay. And uh, dryness fraction is 1. P2 is your 0.95 bar. Okay. And frictional loss is 10 percentage of heat drop. Okay. So nozzle coefficient is 100 percentage minus 10 percentage, means nozzle is having only 90 percentage efficiency, not 100% efficiency, because 10 percentage of the heat loss takes place. Okay. So that is represented by symbol K. Just you remember, don't make confusion. Just it is a how much amount of the heat is lost. That is 100% minus 10%. That is 90%. You have to put it in a decimal point. That is zero point 0.9. And exit diameter of the nozzle is your 12 mm. You have to convert that 12 mm in terms of meter. That is 12 divided by 1000. That is 12 into 10 to the power of minus 3 meter. This is first you have to write the given data. Then so you have to recall your mass balance equation. What is the mass balance equation? A1 C1 divided by V1 equals to A2 C2 by V2, where A2 is your what? And you remember, so we are going to concentrate only at the exit, because inlet the velocity is negligible. Our aim is to find out what is the parameters at the exit, not at the inlet, because the nozzle is the kinetic energy increasing device. Okay, so mass flow rate is A2 C2 divided by V2, where A2 is cross sectional area of the nozzle at exit, C2 is velocity of steam at the exit, and V is what? Volume of the steam at the exit in terms of meter cube. This is in terms of meter square, C is in terms of meter per second, and V is in terms of meter cube. So this is the formula, very simple formula. A1 C1 by V1 equals to A2 C2 by V2. That is a mass balance equation. Okay. Now, first, we don't know A2. How to calculate A2? By using the formula pi by 4 into d square. Here, diameter of the nozzle at exit is given. That is 12 mm. First part is you have to calculate your A2. That is pi by 4 into d2 square. That is pi by 4 into, and you remember, don't put it in mm. You have to convert in meters. 12 into 10 power minus 3 whole square. You'll get 1.1 into 10 to the power of minus 4 meter square. So the units plays very important role. Okay, everything you have to convert properly. Celsius into Kelvin, mm into meter, and all bar into your kilogram units, etc. Okay. Then what is the formula? C2 is same formula you used, how you used in the first problem, same formula. That is 2000 into K. What is K here? Some 10 percentage of heat loss takes place, but that's why you have to consider, don't consider 100 percentage. That is, K is nothing but your nozzle coefficient. 10 percentage of drop means what? 90 percentage of efficiency. You have to take, it is 0.9. Instead of taking 1, just you have to take it is 0.9 into H1 minus H2. Okay, here most important thing, how to find out your H1. Okay, so you hope you understood how to see the values from your Mollier chart. In the previous class we explained. Okay, so what is the initial condition? So that is P1 is 12 bar, and T1 is how much? T1 is your P1 is 12 bar, and one more thing, they are not given the temperature, rather than they have given the dryness fraction as 1. As I said in the previous class, okay, the dryness fraction is 1 and P1 is 12 bar. Okay, so just I'll go through that 12 bar and 1 bar. 12 bar dryness fraction is 1 and 1. Okay, this is the Mollier diagram what we discussed. Okay, then here in the problem what they are given 12 bar and dryness fraction as 1, and second one is what 0.95 bar. Okay, the condition of the steam 12 bar and dryness fraction as 1. Okay, where will get the dryness fraction as exactly 1 in case of the saturated line. And what all these lines what I say, these are the dryness fraction lines below 1. Okay, and the condition of steam is wet in this zone, and here the condition of steam is super saturated in above region. Now our aim is to find out the enthalpy at point 1. Okay, so they are given 12 bar and dryness fraction as 1. As I say, dryness fraction 1 will get exactly on this thick line, that is saturated line. And one more condition is 12 bar. You see, as I said, blue lines are your pressure lines. You see 0.2 bar, 0.5 bar, 1 bar, 2 bar, 4 bar, like that. But here 12 bar is not, I am not finding 12 bar, but you can refer the nearest value, that is 10 bar. 10 bar, just you come down, scroll down this one, 10 bar. So where it meets your dryness fraction as 1, you see this is the line. Okay, so this is how to get the value of H1. Okay, otherwise they'll give 12 bar and 400 degrees Celsius, like that. But in this case, the temperature not given. Okay, so temperature not given means, but they'll give the two condition, that is X is 1 and the pressure is 10 bar. So we first scroll down 10, where it intersects your red thick line. Okay, this is your the intersection point. So as I said, how to find out the enthalpy? Just you keep the scale and come here. Okay, so this is your the value of H1. How much? 2500, 600, 700, and 2800. Approximately you are getting this much of value. Okay, 2800. Then how to find out your second point? Okay, how to find, this is the H1 by knowing 10 bar pressure and X as 1. Understood
So,
this one? Are you following?
so
Visible?
it's not properly overlapping that line. So we will take the approximate value, or we have to make some value.
Correct. No,
Means
because
we have.
in the problem they are given 12 bar. Okay, it's not 12 bar is
Yeah.
not there. Okay, this I said 10 bar is there. Na? Yeah, are you able to see 10 bar? Okay, what time? Keeping the cursor 10
So,
bar.
sir, I'm telling
Okay.
the intersection point is not
Uh,
overlapping the
uh,
means graphical line. So
Correct.
we
But
will take the
uh,
value
approximate value you have to take care. Okay.
approximate. Oh,
No, okay. Just the intersection point, you say. Actually, in the problem, they are given a 12 bar and dryness fraction as 1. Okay. Dryness fraction line is, I said, this is the X equals to 1. Okay. Understood this one. X is 1. Dryness fraction line. Okay,
yeah.
where your 10 bar. Okay, because 12 bar I'm not finding out. If it is 15 bar, directly you can take. You see, you can observe one line in between 10 bar and 20 bar. Okay, this is your 15 bar pressure. But in the problem, they have given 12 bar and dryness fraction as 1. Okay, 12 means you cannot take 15, right? It is not 15, but 10 bar. You see this bar 10 they have clearly mentioned. Just you scroll down this line. Okay, what I'm scrolling, you see the cursor. Okay, this is the 10 bar pressure, come down. Okay, come down, come here, where it intersects your X equals to 1. This is your intersection point. Understood this one? This is the intersection point. Okay, any doubts how to find out the intersection point? Okay, any doubts, guys? This is how to find out intersection point. First you have to analyze the intersection point, then only you can find out H1. Okay, very simple, just intersection point. Two conditions they will give, one is pressure, one is temperature, or pressure and dryness fraction. Okay, so temperature lines means what, your the green lines. Okay, but in this problem they are not given the temperature, rather they are given X is 1. X is 1 here. Okay, this is thick line is your saturated line. So where your 10 bar pressure coincides with your dryness fraction line, which is having the value of X equals to 1. Okay, this is your intersection point. Okay, so then how to find out your enthalpy? Just you keep the scale. Okay, you are getting very nearest to your 2800. Okay, so we are not getting exactly on the horizontal line, but we will getting something below, means which is nearer to your 2800. In that case, you can write approximate value because no exact value is there. 2700, 2800 means you can write 2750 like that. If it is lies in between, don't write 2800. Suppose if that point lies exactly on that line, you can take the exact values. So each line indicates 100 kilojoules per kg, 2500, 2600, 2700, 2800. Okay, so condition of steam at inlet is 12 bar. Okay, using Mollier diagrams, you will not get the exact value. You have to take the nearest value. Okay, remember, if it is 18 bar pressure, don't take this one directly, you take 20 bar pressure. Okay, because 18 is nearer to your 20. Okay, if it is 15, directly you take the line in between 10 and 20. If it is 10, 11, 12 like that, you directly go for 10. Don't consider the middle one. If it is 18, 19 or 20, 21, 22 also, you can take the only the pressure lines of 20 bar. Okay, don't go for any other line. So this 20 lines, 17
Sir, if it
means
is
you have to
17,
take this value. This middle line is there, no? Middle line between 10 and 20.
that is 15
15,
also.
but intersection point means 17. You can go for this one only, or 20 only, no problem. Okay, for 17 you can go for 20. This 14, 15 or 16. Okay, 14, 15 you can take this line, middle line. Okay, it is like your 0.5. Okay, 0.5, it is less than 0.5, you have to take the inner one. If it is more than 0.5, we can take the outer line, like that only, same thing. Okay, so this no, no, actually, 10, 11, 12, okay, you can take this 10 bar pressure only. Suppose if it is 15 exactly, in that case, you take middle one. Suppose if it is 16, 17, 18 like that, you can take this 20 bar pressure only, okay, above 15, okay. And if it is less than 15, you can take the 10 bar pressure. Okay, because we don't have the lines in this one. But in actual Mollier diagram, what you are getting in the exam, you'll get exactly all 10, 11, 12, everything will get it. But whatever I am explaining in the chart is, it is not there. Okay, that's why I considered that the line. Okay, but in the exam, what you are getting, you'll get the big Mollier diagram. It is provided at the end of steam tables. All values are there, 10, 11, 12, exact value you'll get it from that Mollier diagram. You remember? Understood? Okay.
Sure.
Now in the exam, what you are getting Mollier diagram, no, you will get exact value, 11, 12 bar, 13 bar, everything is there. All lines are there. Okay. Small lines are there. Okay. For this one explanation purpose, I took this diagram, small diagram. Okay. But it is very big diagram. Okay. Means it indicates every bar, 10, 11, 12, 13, every all exact value you'll get it. Okay. From that big Mollier diagram. Okay. Suppose anybody is having a steam table, it is there at the end of the steam table. Just you go through that steam tables, you'll come to know the how to find out. Okay. If anybody is having, please let me know. Okay. Anybody is having the steam tables with you? Hard copy. Okay. Anyone is having? Okay, no problem. So that for this explanation purpose, I took this diagram. But in actual Mollier diagram, what you are getting in the exam, you'll have the accurate values. Okay, 10 bar, even 11 is there, 12, everything is there in that Mollier diagram. So it is around a very big diagram you'll find at the end of the steam tables. Okay, so this one, how to find it is, I took, because 12 is nearest to 10 bar, I took 10 bar. And where is the coincide point? So it is x is 1. Okay, so this is the intersection point. Then how to find out your h1 is, just you keep the scale. As I said, it is nearer to 2800, but it is not exactly on the 2800 line. So you can write around 2750 or 2780. If it is very close, you can write the approximate value, not accurate value. I am telling. Suppose if you are having that diagram, you will come to know accurate value. Okay, I am putting here approximate value as 2750 something. Okay, then how to find out your second part, that is it is expanded to a pressure of 0.95 bar. Okay, as I said, okay, first for this one we are going to find out first intersection point 10 bar and your dryness fraction as one. Then how to find out your second value? It is at a pressure of 0.95 bar. Okay, so what is a 0.95 bar? Here I am not finding out any 0.95 bar. So what is the nearest value of 0.95 bar? And anybody, what is the value nearest to the 0.95 bar? Is nothing but your 0.1 bar. Okay, 0.95 bar and 0.1 bar. Here you can find out this 0.1 bar pressure is there. Okay, 0.1 bar
So
pressure.
0.95 will be close to 1 bar.
One, sorry, 1 bar. Good. Okay. Correct. Okay. So what I said, good. Exactly right. Okay. So 0.95 bar is exactly equals to 1 bar. Okay. First, as I said, first you have to look at the first intersection point. What is that? 10 bar pressure and 1 x equals to 1. Starting we found out that is 10 bar pressure and your dryness fraction as 1. Here you are getting the 10 bar pressure. What is starting point? Okay, what we got this one. Okay, this is your starting point. Okay, next how to find out your second value, that is 1 bar. Okay, now what I said, in order to find out second value you have to draw the perpendicular line from that intersection point of 1. So you have to draw perpendicular line where your pressure is 1 bar. Okay, from this one, okay, you have to draw the perpendicular line. Where is your 1 bar? This is your 1 bar. Okay, understood? This, sorry, this is your 2 bar and this is your 1 bar pressure. Okay, this is your hope, this is your 1 bar pressure. Exactly, this is the point 2. How to, you analyze just how to find out the point 2. Okay, first important thing is location of point 1, and how to locate the point 2 is just drawing the perpendicular line from the initial point. Okay, 10 bar pressure. Okay, this line, and x is 1. Okay, starting what we are getting this one. And how to find out second value is you have to find out P2 as 1 bar. Okay, where is the 1 bar line? So this is your 2 bar and this is your 1 bar. Okay, understood? This is how to locate your P2 point. Then how to find out H2 means just you put the scale here and you have to drag down. Okay, so it is one line below 2500, means approximately we are getting the value as 2400 kilojoules per kg. Okay, understood? Any doubts in this one? How to find out H2 value? Okay,
Sir,
understood how to find out H2 value?
sir, I have a doubt. What if the pressure is given as 500 bar and x is equal to 1? Then how do you find the intersection point?
How much? What is the condition? 500 bar.
500 bar and x is equal to 1. Then how do
Okay,
you
good.
find the
Okay.
intersection?
Good. Okay. So here, so such kind of pressure means it is going beyond the line. Okay, 500 bar is there. Okay, understood. And then your 500 bar and x equals to 1, right?
Yes, sir.
No, it's not possible here because we'll get the, like, you see, this extreme bar. Okay, 500 bar, such kind of bar is not available. So the approximate value you are getting it as 2600 kilojoules per kg, and that bar does not lie on your saturated curve. Okay, up to 200 bar pressure we can expand in a nozzle. You see, maximum range is 200 bar. You see, you can see the line 200 bar that lies on your, not to 200. Okay, it's still less, around 150 bar maximum we can expand in a nozzle. Okay, 500 bar is not possible here. Okay, in nozzle. That much of pressure is not possible, and x equals to 1 is also not possible. Whenever you're expanding 500 bar, no, it is always x is greater than 1. You remember, that is very huge pressure. Okay, and will not get x equals to exactly 1. Okay, for lower pressure only we are getting the value of x equals to 1 and x is less than 1. You remember, for higher pressure that does not lie on your saturated line, it is beyond the saturation line. Okay, 500 bar, but you can find out but on in that case you can, they'll give two conditions, 500 bar and you can tell any one temperature. I'll tell the value, exact value. Okay, but this condition is not possible. 500 bar and x equals to 1, not possible at all. Okay, because there is a very huge pressure and that is superheated steam. Okay, remember, it is above dry saturated line. Okay.
Yes, sir.
Yeah, and suppose you can find out 500 bar I'm taking, and one more temperature, whatever temperature I'm taking 600 degrees Celsius. In that case, it is very easy to find out the H1. Okay, 500 bar is there. Okay, you can see the blue line, and you can see the green line. What is that? Around 500 degrees Celsius. You can take this line as 500 degrees Celsius. Okay, this 500 bar, and where it coincides with your 500 degrees Celsius. Okay, where is that one? This line, 500 degrees Celsius. This line. Okay, this line, 500 degrees Celsius. Okay, so where 500 bar you take, and you can take the particular temperature line. Okay, this is your 500 degrees Celsius, whatever you take temperature line. So you can take left side around 3100 kilojoules per kg. Suppose 500 bar and 750 degrees Celsius. First line only you can consider. This is a 500 bar and this is your 750 degrees Celsius. So this is your intersection point. It is in superheated steam only, means heat content is very high. Okay, so 500 bar and 750 degrees Celsius. Keep left here. This one what? 3600, 700, 800, 3800 kilojoules you will get at 500 bar and 750 degrees Celsius. Okay, the steam is in superheated state. You remember, 500 bar and 750 degrees Celsius. So in this case, we are going to concentrate mainly on pressure and temperature in this zone. Okay, and in this zone, we are going to concentrate mainly on your pressure lines and dryness fraction line. You remember, because the temperature is below 100 degrees Celsius. The steam is in wet condition. Whatever the temperature, the above saturation line is above 100 degrees Celsius. Okay, remember. So in this zone, the temperature lines and pressure lines comes into picture, and whatever in the wet steam, so the temperature, sorry, dryness fraction lines and pressure lines comes into picture. Very simple. Okay, here you remember dryness fraction and pressure, and here temperature and pressure. Very simple. So that is intersection of temperature and pressure you have to consider here, and here the intersection of pressure and your dryness fraction. What are the dryness fraction lines? Red lines. Okay, any doubts? Okay, any doubts, guys? Okay, how to locate the points is most important in this Mollier diagram. Okay, whatever condition you take, very simple, just you have to scroll. Okay, so what is the first column? P1 is 10 bar and X is 1. Okay, where you are getting, just you scroll down where it cuts that line on the red line. Okay, this is your intersection point. And P2 is your what? 0.95 bar is given in the problem, but 0.95 is not there. It is 1 bar. So that just you keep the scale and draw perpendicular line where it cuts your 1 bar pressure. Okay, this is your 1 bar pressure. Okay, so this is a P2. Okay, this is the most important. Keep the scale, draw the vertical line and locate the point 2, and then just you come left. Okay, this is your 2400 kilojoules per kg. Okay, very simple. Okay, you have to locate H1 and H2. That's it. Okay, otherwise you can find out from your steam table also. Okay, that is also possible as I shared. Okay, so P1 is your 12 bar and P1 is 10 bar and X1 is X equals to 1. What are the values? You can find out from a steam table also, and but the values varies. You will not get accurate value in the Mollier diagram. Understood? How to locate? Okay. Any doubts? How to locate the points? 1 and 2, you know. Okay, now I'll come back to my problem. Okay, just I explained how to see the values from the Mollier diagram. Okay, now I want to find out H1 and H2. Okay, same thing they have explained for a corresponding to pressure of P1 equals to 12 bar. As I said, it is approximately 2,800. Okay, we can, but whatever the chart you are getting in the exam, you get accurate value, but I'm putting the approximate value. As I said, 2,800. Okay, same thing we are getting here, corresponding to pressure of 12 bar and dryness fraction as 1. We are getting the value of H1 as 2,800 kilojoules per kg in case of Mollier chart. Okay, so you take 2,800 only, no problem. And then how to find out your H2 is just you have to draw perpendicular line, and then where it cuts 1 bar, because we don't have 0.95 bar in our existing Mollier diagram, you can take 1 bar. Okay, then so you have to drag down so that locate the point 2, then keep the scale, find out the value of H2. What I say 2,400. Okay, here 2,800, no problem. Okay, we can take H1 as 2,800 and H2 as 2,400. Okay, because we'll not get accurate value, we have to take the nearest value. Okay, okay, this is the how to find out the value of H1 and H2. Okay, next, as I said, uh, how to find out your C2. Okay, same formula you apply. Okay, same formula. Here in the first problem, I explained with the formula. In this problem with the Mollier diagram, how to find out the values of H1 and H2. And once again, use the formula. Okay, so use the formula. We can find out H1 and H2. H1 minus H2. Okay, so directly you can find out. Okay, we got the value of H1 minus H2 as your 2,800 minus 2,400. How much you get? 400 kilojoules per kg Kelvin. And you can find out the using the formula square root of 2,000 into 2,800 minus 2,400. By substituting the value, you will get the value of C2. Okay, this is how to find out the value of C2. Mainly, you concentrate on how to find out the values of H1 and H2. That is most important. Okay, and another formula you can apply. Okay, what I said, square root of Cp into T1 minus T2. Okay, so T1 is given in the problem. T1 is not, T1 is,
Sir, the page is repeating.
okay, repeating. Okay, okay.
Sir, page number 265 is repeating.
Okay, okay, just a minute. Okay, good, good. Okay, sorry. Okay, so I'll explain that page is not displayed here. Okay, sorry. Just you remember it's the 265 page number. 266 is not this one. It's not there. Okay. 265 only I'll explain. Okay. So how to find out the value of C2 is your square root of 2000 into H1 minus H2. Our aim is to find out the value at the exit. What is H1? Is 2800 minus 2400. What is the value you'll get? Square root of 2000 into 400. Okay. How much you'll get? The answer as just you calculate, you'll get the answer at answer for the velocity at exit is, after simplifying, you'll get 867.4. Okay, remember 2000 as it is, k is your what? 0.9 nozzle coefficient. Otherwise you have to consider 1. In this problem they have given 10% of heat losses, means you have to take 0.9. 2000 into 0.9 into what? H1 is 2800 minus 2400. By simplifying, you'll get the velocity at the exit as around 870. Just you go through and calculate that value. Okay, around 870 meter per second we'll get. And one more thing, how to calculate your mass flow rate. Okay, mass flow rate. So mass flow rate is, so before that, so what I explained, you have to find out what is the dryness fraction line. So for this one, okay, dryness fraction of, we know P1 is how much? It is 1. But for second point, we know only the bar pressure, but we don't know dryness fraction. Why we need the dryness fraction is, we are having the formula V equals to X into V. Okay, X into V. That is the specific volume at point 2 is given by the dryness fraction multiplied by your V G2. Okay. So I'll explain how to find out the dryness fraction for that particular point. Okay. So just now we found out what is the H1 and H2, 2800 and 2400 what we got. But what is your dryness fraction? Okay, P1 is 10 bar and it is X equals to 1. And where you got that point intersection point for point 2, that is 1 bar. Sorry, 1 bar is means you are scrolling down. It is 1 bar pressure. Okay, you see the line nearest to this point is your 0.9. So you see it's very close to 0.9. Okay, hence you have to consider the dryness fraction as 0.9. Suppose if it is nearer to this point, you can take 0.85. So whatever point what I am getting here is your 0.9. So this is how to find out the dryness fraction at point 2. If for point 1, the value of H and so value of P and X is given. For point 2, the dryness fraction is not given. Okay, for P2 as 1 bar and what value you are getting, dryness fraction is 0.9. The value which is nearest to that line, that is a red thin line, you have to consider that dryness fraction. So why you are considering that dryness fraction means, we are having the total volume equals to X into specific volume, X2 into specific volume. Okay, so you remember the volume, total volume at point 2 is V2 equals to X2 into small v2. Small v2 is your specific volume. Then once again, you have to find out these values from the steam tables. Okay, as I said, you have to refer the steam table. Okay, share the steam table. Okay, so for corresponding to pressure of 0.9 by 5 bar, okay, you see what is your temperature based table, and for pressure based table, how to find out small v2. Okay, we found out dryness fraction using your Mollier diagram. Then how to find out the specific volume. Okay, specific volume for 0.95 bar. Okay, so you are going to find out dryness fraction using Mollier diagram, and you are going to find out the specific volume using your steam tables. You see, this is pressure is 0.9 by 5 bar. I think you are going to observe here. And what is V2? The V2 value is around 1.777. Okay, so why you are using this? Capital V2 equals to x2 into small v2. X2 means what? Just now we found out 0.9, and small v2 is what? Your 1.77. So using this one, you are getting capital V2. What is capital V2? 1.77 into 0.9, what we are getting from Mollier diagram. So you are getting around 1.528. Okay, you remember, so you will not get using the Mollier diagram this value. You have to refer steam tables. Corresponding to pressure of 0.95 bar, we are getting the value of small v2. Small v2 is nothing but your specific volume. Capital V equals to x into v2. X is 0.9 into 1.77. You'll get around 1.528. Okay, then what is the mass flow rate? We are having the equation what? M dot equals to A2C2 divided by a small v2. Okay, you are
Sir, it's a break, sir.
break. Huh? Okay, no problem. Hope you understood that problem. You understood now how to see the Mollier diagram. Okay.
Almost, yes, sir.
Okay, good. Okay, I'll stop the session here only. Okay, so you try to do some more problems related to this one, just to analyze. Okay, any doubts? Let me know. Okay, and all of you have to enter your USN in the chat box, sir, without fail. Okay, so for attendance purpose, don't forget to write the USN in the chat box. Okay, without fail. I am repeating once again. Okay. Thank you one and all for joining the meeting. Okay, thank you.
Thank you, sir.
Thank you, sir.